Okay, so 1, 1 through 1, 1, 1, 2, 1, 3. We've talked about all these things. We've talked about domain, range, intercepts. We talked about that, I think, in the last section, right? We've talked about symmetry. We've talked about end behavior in the last section. We talked about extrema in the last section. This part, this increasing, decreasing, is going to be kind of like the new stuff today. And honestly, it's not even. Just how they write it can be a little confusing. But pretty much today what you're doing for me is you're sketching graphs, just given like a list of like information about it. So it is a lot of reading, but I don't think it takes a ton of time. So the first thing I'm going to ask you to do is sketch a linear function. And honestly, this example is harder than your homework assignment, because can you guys tell me what is the rule? Does anyone remember about the rule for lines in geometry? How many points make a line? 2 points. And on your homework, so on this example, I only give you 1 point, right? I give you a y-intercept. There is an x-intercept that's hiding in here, but I don't like straight up tell you. But on your homework assignment, I do tell you your x-intercept and your y-intercept. So the first 2 examples, you should breeze through, because as long as you know it's linear, 2 points make a line. So in this example, though, I give you the y-intercept, the linearity, just so that we know it's linear. This part, this positive and decreasing, this is sort of like the tricky part. And then the end behavior, this is more of a check for yourself afterwards. I'm not sure that end behavior necessarily helps you draw these. But since I know this is linear, let's start with this y-intercept. So I do need to count by, what did I count by? I think I counted by 20s here. So this is 20, 40, 60, 80. It's going to label every other. Then just so it looks nice, I'll count the same on the x-axis, 20, 40, 60, 80, negative 20, negative 40, negative 60, negative 80, negative 20, negative 40, negative 60, negative 80. Your homework assignment, I even labeled the x and y axis for, I think they're all counting by ones. But it is labeled. It's really hard to read, though. I couldn't make it print larger. But in general, if it's not labeled, you guys need to label what you're counting by. I always tell students, treat me like I'm a dummy, so that you just make it super obvious for when I grade it. So let's start with this y-intercept, 0, negative 70. So I'm going to go x, 0, and then I'm going to go down 70, so halfway between negative 60 and negative 80. Now my x-intercept, this is the part that's sort of hiding. So it's decreasing for all values of x. What that means is this line is going to be going down. This is not a positive slope, right? This is a negative slope. But this positive for values of x, it's talking about y is positive. Y is positive for values of x such that x is less than negative 30. So what that means is at the point where x is negative 30, so I'll put a point right here, it is positive above that and negative everywhere below that. So do you guys see how that's my x-intercept just hiding? Like they couldn't just tell us it was an x-intercept, but it is. I do have rulers if we want them today. But 2 points makes a line. And there's my line. And then I can just check with my end behavior. Remember, this is saying as x goes to, actually, I have this backwards from how we did it yesterday or last week, but that's fine. As x goes to positive infinity, so as you look to the right, the function's going down. As you look to the left, as x goes to negative infinity, the function's going up. Sorry, that switched. I don't know why the book would do that to us, but oh well. Any questions about example 1? So the end behavior is really just a little check for yourself. Let me get this before I flip. All right, so example 2, sketch a nonlinear function. Now, this could be really complicated. I'm going to tell you right now, we're not going to make it really complicated. It's not going to be some like crazy, super bumpy thing. It's probably going to be some kind of polynomial, so like an x to the second, x to the third, x to the fourth, and so on. And the important thing here is going to be your x-intercepts, which again, in this example, it doesn't list the x-intercepts, but on your homework it does. So it should be pretty quick. So what we do have here, we have our y-intercept. So always start with your y-intercepts if possible. I know that this is nonlinear. The fact that it's continuous, again, if I were to be a really mean teacher and give you something discrete or discontinuous, that'd be awful. It should be continuous. Positive for all values of x. What that means is I am not going to go below, I'm not going to go into the negative y's at any point. It needs to stay well above that. Decreasing for all values of x such that x is less than 0. So we'll come back to this. My extrema, I have a minimum at 0, 3. And then my end behavior, again, is just a final check. So let's go ahead and label. I counted by 2s here. So 2, 4, 6, 8, 10. And you can just, like, if you want to label the top one, as long as you put the lines, I can assume, okay, there's 5 spaces there up to 10. We're counting by 2s. 2, 4, 6, 8, 10. And again, I labeled your homework, so you don't even have to do this part. Negative 2, negative 4, negative 6, negative 8, negative 10. Negative 2, negative 4, negative 6, negative 8, negative 10. Let's start with that y-intercept. So our y-intercept is at 0, 3. This is counting by 2s, so it's halfway between 2 and 4. And then also, so that's my y-intercept. Also, note that that's the minimum. So we should not go below this line. Now let's think about what this means. So it's decreasing for all values of x such that x is less than 0. So everywhere this is x is less than 0, it should be going down. So this is going to be going down everywhere that x is less than 0. And now here my end behavior does tell me what to do on the other side. So again, I don't know why I have this flipped. We'll fix that for next time. But as x goes to infinity, so as you look to the right, it says that your function should be going back up to positive infinity. So this should be going back up. So this is just a real nice parabola. So this told us that last piece of information that we need to be going back up. The other thing that tells us that is the fact that it says it's decreasing for all values of x that are less than 0. So by saying it's less than 0, if it says it's just that range, it has to be increasing everywhere else, right? Or it has to be flat everywhere else. Questions about that one? The nonlinear are a little trickier. I give you more information on your homework, honestly. I give you one real world situation. I actually almost think these are easier. It's more reading, but I do think they're more straightforward a lot of times. So this one's about a test drive. So it says, Hay is test driving a car she's thinking of buying. She decides to accelerate to 60 miles per hour and then decelerate to a stop to test its acceleration and brakes. It takes her 15 seconds to reach her maximum speed and 15 seconds to come to a stop. Use the key features to sketch a graph that shows the speed y as a function of time x. So her maximum speed here is 60 miles per hour. And it takes her 15 seconds to get to that maximum speed. So if you think about this different information, let's start with the extrema because I can see that right there. So the extrema, our maximum speed, max speed, was 60 miles per hour. And that happened at 15 seconds. Well, if you think about this in terms of x and y, speed is y, time is x. So if I made this into a coordinate point, it would be 15, 60. They've already labeled this first, so that's nice. Then the other extrema is that she stops again. So stops after another 15 seconds. So what's 15 plus 15? 30. So if she stops, she's going 0. And it's taken now a total of 30 seconds. Okay, see how you can like kind of talk yourselves through that? Here's a question. The y-intercept, what does she start at? At 0 seconds, what should her speed be? Unless she's like an action hero. 0, right? We generally don't jump into moving cars. So our y-intercept should be at 0, 0. Starts at 0 miles per hour. Because that's what normal people do. All right, so now this next part is a little more, because I believe that there are some cars that don't accelerate. In fact, I remember I had a friend that was super into cars, and like most cars don't increase or decrease at like a steady rate, but we're gonna assume this car does. So this increasing, decreasing stuff, so it's going to increase at, we'll say, a uniform rate. Uniform rate. Meaning that this doesn't have any curves in it. This should be a straight line connecting. Does that make sense? Now, typically, I would actually think that it would be more like a bell curve or something. Don't you guys think? But we're going to assume it's a uniform rate because I don't know. I could see an argument. It doesn't necessarily say that. So I could see an argument where you don't think that, but the book says it's a uniform rate, so we'll go with it. So it also decreases at a uniform rate. So at a uniform rate. So what that means in terms of our lines, anytime you see like the words uniform rate, it would be like a straight line. If you see a decreasing rate, it would be some kind of exponential, or an increasing rate would also be exponential where there's some curve to it. But this has no curve. So just draw a straight line from there to there, straight line from there to there. Her whole test drive took 30 seconds. Is this linear or nonlinear? It's nonlinear. Even though they're straight lines, they're not. It's two different directions. And then our end behavior, I'm not even going to do that because that doesn't help us. And I give it to you in the homework assignment. So I think, actually, do I even give it to you in the homework assignment? I don't think it even matters in the homework assignment. No, I don't. Okay, so this is as like complicated as that example gets. In the homework assignment, I just realized I don't give you like any spaces to write like the intercept. So you're gonna have to just kind of read it and like draw it out more. The bottom is time, the top is speed, and I don't have these labeled. So you will have to like put what you're counting by for this. So the total time for number 5 should be 20 minutes. So your total time needs to go up to 20 here. And then your maximum speed is 35. So this should go at least to 35. You can go to 40 if you want to count by 5s. Okay? Let me get this for you.